Find the Laplace transform of 3t to the fourth minus 2t squared minus 1. So based on the principles of linearity, you can split this up such that each individual term of the sum can be isolated. So taking the 3 as the coefficient, you can then multiply that by the Laplace of just t to the fourth. And then from that, you can subtract 2 times the Laplace of t squared. And lastly, minus the Laplace of 1. From here, we need to understand the basic property of the Laplace transform of t to the n power. From our table, this is given to be n factorial from the exponent over s to the power of n plus 1, where n is any integer, 1, 2, 3, and so on. So looking at this first term, we have 3 times Laplace of t to the fourth. Using this logic, Laplace of t to the fourth is letting n equal 4. So this becomes 4 factorial over s to the 4 plus 1, which equals 4 times 3 times 2 times 1 over s to the fifth. And we know 4 times 3 is 12, times 2 is 24, times 1 is still 24, so you end up with 24 over s to the fifth. Now for our t squared term, Laplace of t squared means that now n equals 2. So this is a little simpler. N factorial is now 2 factorial over s to the n plus 1 becomes 2 plus 1. So it's 2 times 1 over s cubed, which equals 2 over s cubed. And our last property is the basic Laplace transform of 1, and from our book, that's 1 over s, given that, of course, s is greater than 0. Now, plugging all of these terms in to our equation we have up here, we have 3 times our 24 over s to the fifth term minus 2 times 2 over s cubed minus 1 over s. Simplifying for our final answer, 3 times 24 is 72. So it's 72 over s to the fifth minus 2 times 2 is 4 over s cubed minus 1 over s. And that's our answer for this Laplace transform. I hope this video made sense. If it did, please like and subscribe, and I'll see you in the next one.